Okay, we are going to start in lesson 2. We're going to get through session 1 in this video. As always, each lesson starts with a family letter. Take this, read it through with your families. You can tear it out and give it to them if you would like to. You don't have to do that, but it allows them to know what we're covering in this lesson. So I'll read through some of this and touch on some important points, and then you can have, after the video is over and you have some time, you can look at it yourself. So this week, your student, you, is learning to find the area of triangles and other polygons. You can use formulas to find the area of some polygons. A rectangle, which we talked about in class, was the base times height. Parallelogram, remember that base times height. You take the string to the corner, drop it to get your height. And the triangle, which is 1/2 of our base times height. This triangle is new for lesson 1. So, as you can see here, those are formulas. It's showing your family how to solve so they can help you. I get it. It's been a while since some of them have been in school and might need refreshers. I always need a refresher on some things too. There's an activity you can work on with your families if you would like. But this is where we're going to start today. We're going to start on page 21 in your math textbook. It looks like just this, lesson 2, session 1. We're going to explore the area of a triangle. And I'm going to move my page over so I have more room to write. And we're going to go and get started. Remember, books should be out in front of you right now. You should be good to go. You're paying attention. You pause when needed. Don't worry about erasing. I love to see your thought processes, so you don't have to erase, but you can just X out or just move on and use other space if you want to add to it or change. So we're exploring the area of a triangle. Previously, you learned about finding the area of a parallelogram. In this lesson, you will learn about finding the area of a triangle. Use what you know to solve the problem below. Caitlin has 2 decals shaped like triangles. She arranges them on the back of her skateboard to form a parallelogram. Each grid square represents 1 square inch. What area do the 2 decals cover? It's a lot of information to process. I'm going to read it again, and this time, underline, highlight, pull out information that I think is important. I'm also going to point out that there might be a word that you struggle with vocabulary-wise. That word might be decal. A decal is like a sticker. So think of it like a sticker on a skateboard. They gave you a picture at the top of your page right here. Okay, that picture shows the 2 stickers, or a sticker, to show you what it would look like on the skateboard. So Caitlin has 2 decals, so 2 triangles. That's here 1. Oops. So that's triangle number 1 and triangle number 2. So we have 2 of our triangles that we're working with. She arranges them on the back of her skateboard to form a parallelogram. So that word parallelogram right there. Each grid square represents 1 square inch. So we know, once we are done with this, that we're going to be working with square inches. Okay, so we know that our unit of measure is going to be inches squared. What area do the 2 decals cover? So we're trying to find the area of the 2 triangles. Go ahead, hit pause, give yourself a minute, reread the problem, and try to solve on your own. Okay, I'm going to start with what we know. We know that the area of a parallelogram is base times height. We know that. We've dealt with it. We've talked about it. You've taken a quiz. We know the area is base times height. We know that the base, of triangle number 1 is 1, 2, 3, 4, 5, 6, 7, 8. So the base of this triangle is 8. The base of 1, 2, 3, 4, 5, 6, 7, 8. We know the base of triangle 2 is also 8. Okay, and we're talking about height. Remember, we go to our vertex. We drop that string down. We know the height here is 1, 2, 3. And we also know the height here is 3. We know they're the same triangles. The base is 8. The height is 3 for both triangles. Okay. Before we go any further, that's what we know. So we're not focusing on what we don't know. We're focusing on what we do know. We know the base. We know the height. We know the area of a parallelogram. When we're looking at these 2, could we take these two triangles and make them into a parallelogram? Could we cut them and move them? If we cut this piece off right here, could that piece go over here? Could we cut the remainder and lay it here? Yeah. So then we're making a rectangle, which is a parallelogram. So when we're doing that, we're taking our base of 8, our height of 3. Remember, substitution. My area is 8 times 3. 8 times 3 is 24. It's not just 24 though. Remember, our answer here is going to be 24 inches squared. Okay, make sure you have this work in your book. If you solved it a different way, make a note to share it with me when I see you again next week, just so we can talk about it. And I want to see how you solved, not just how I solved. On our first page, we know that the base was 8, the height is 3. We know that the two triangles form a parallelogram, and that's how we got our 20. Over to page 22. Okay, this page is taking what we just did and putting it into words. So that way we have a good foundation and we have a good understanding of what we did. So look back. What area do Caitlin's two decals cover? Explain how you know. Well, if we look back, since we took such good note, inches squared. So when we have to actually answer this question, okay, so the first question is, what area do they cover? They cover 24 inches squared. We have that solved on the first page. Okay, we're going to use one of those keywords that we used in class. We talked about decomposing and composing. Okay, we composed the two triangles to form one parallelogram. Oops, and even I make spelling errors here. I'm still learning how to write on here. Obviously, that was not the right tool. I apologize. We'll just leave it for now. Compose the two triangles to form one parallelogram. Okay, and we know the area of a parallelogram is area equals base times height. Look ahead. As in a parallelogram, the base and height of a triangle are perpendicular. Any side of a triangle can be called the base. The corresponding height is drawn from the vertex that is opposite the base. What? That's a lot of words. So let's break this down. As in a parallelogram, the base and height of a triangle are perpendicular. Remember, if you look back to our vocabulary, perpendicular are two lines that meet at a 90-degree angle. Okay, so when we're talking about perpendicular, we're talking about two lines that meet at a 90-degree angle. So our height and our base meet at a 90. So if you see here, that 90-degree, that symbol is showing they're perpendicular. They meet at a 90-degree angle. Any side of a triangle can be the base. Well, can we take a triangle and turn it? Absolutely. These two triangles are the same, they're just turned. The corresponding, meaning the matching height, is drawn from the vertex that is opposite the base. So what that means is you go to